Yes, so dear students, now let us begin with our next topic in chapter organisms and population. Uh, yes, so we had left at this point now. So to begin with, let us first revise a concept which we studied in chapter evolution, that unit of natural selection is population. Okay, so you need to just learn this point, and that too for your NEET examination. This topic will not be asked in your CBSE examinations, and I guess neither in Bihar boards also. Okay, so this topic will be in NEET only. It is only for NEET. Now again, going forward, we need to study about age ratio pyramids. Now, what is pyramid? So pyramid is a graphical representation. Pyramid is a graphical representation which is used to represent various parameters. And for this purpose, we make different types of pyramid. For example, the first one, what you can see on your screen is age ratio pyramid. So age ratio pyramid is in which we give a graphical representation of various age group present in a population. So it is a graphical representation of proportion of various age groups in a population. Now this is again of three types: bell shaped, triangular, and urn shaped. So this is a triangular pyramid, which is also known as expanding pyramid. Expanding population age pyramid. How you can say that it is expanding? Look at this. These two represent the reproductive age group, and you can see that pre-reproductive, that is children, are more in number. So if the children are more in number, what it mean is that in 3 4 years, or let it be as 10 years, after 10 years these pre-reproductive age group will convert into reproductive, and it will be larger than the previous one, isn't it? So the larger age pyramid will again give rise to a little more larger pre-reproductive group. So this is how the population expands. Okay, so this is a case of expanding population. Again, a stable population, it is you can say bell shaped. In this, what you see is reproductive and pre-reproductive age groups are equal, means हम दो हमारे दो वाला concept, isn't it? Two people giving rise to next two people offsprings. So the population is stable. So the population is stable in case of bell-shaped graph, bell-shaped age pyramid, better to say. And the next one is declining population. In this declining population, what you see is it is urn shaped. Now, what is urn? Urn is a vessel which is like this. What you see here is urn is thicker in the middle and narrower towards both bases, isn't it? So, like this. Look at this. Now, this is reproductive age group, and what you see is pre-reproductive age group is lesser, means two people giving rise to one offspring. So what you can expect in the next 10 years, that these smaller offsprings will be converting into reproductive age groups after 10 years, and this will lead to a smaller population of reproductive people than it was in the previous time frame. So this is an example of declining population. Again, moving forward, population growth can be represented mathematically and with the help of a graph. Now, let me first introduce you some terms. First is natality. Natality is birth rate. The number of birth during a given period in a population. Okay, so a formula for this is birth rate. New birth by initial population. What does it mean? It means that new births per individual, that is rate. I said na, I guess you must have studied in physics that whenever the term rate is there, per unit is also there. For example, if I say acceleration as rate of change of velocity, what I mean is that rate of change of velocity per unit time. Now again, rate of change of number of people, uh, rate means that it is with respect to some initial population, and time is also there. In what time frame? So this is birth rate, new birth by initial population into that time frame. Now again, in the same way, mortality, death rate, number of individual dying in a population in a given period of time. Immigration means people are coming inside for permanent settlement. It is not like that you go to your granny's home and then return back to your own house. It is not like that. If you are going to a newer place, you are permanently settling at that place. It is like immigration. Inward movement. Immigration is inward movement. New people are being added into the population. Okay. In the same way, immigration is outward movement. Outward movement, people are going outside. Okay. Now again, a term vital index, it is sometimes asked in NEET only. It will not be asked in either in CBSE or in Bihar board, but in NEET. And yes, I guess I can see one more formula which is very important. Number of people after time is initial number of people plus total increase, birth plus inward movement, minus total decrease, death plus total outward movement. Okay. So this is what I was telling you. Now again, growth model. This topic is very important for CBSE as well as Bihar board. These questions are always asked. Growth models. So now, what is a growth model? Growth model is a model being proposed by some scientists that how growth takes place in different kind of population according to their needs, according to the surrounding condition, according to the availability of food and all that factors. So what a growth model says, that the first thing is biotic potential. Let me introduce you to a new term, is like biotic potential. What do you mean by biotic potential? Biotic potential means that how much or maximum potential of an organism to give rise to a new offspring. For example, if you are set free to reproduce, how much organism can you reproduce when there is no limit? No limit. What I mean by no limit is that there is no resistance. Your parents are allowing your pocket. That means you earn so much that you can survive with so many children. So you are all free. What you need to do is to reproduce. So what is the maximum amount of offspring you can produce? That is your biotic potential. And the second term is environmental resistance. So what I mean by this is, for example, we are understanding that no, we should control our population. Population explosion gives rise to many problems. We should produce offspring. We should reproduce in a way that we can survive with them happily. If we cannot, what I mean to say is that if you cannot afford good uh, teachings, schools, good lifestyle to your children, then why to have them, isn't it? Make it a lesser number so that you can live with him happily, him or her happily. Okay. So but In case of other organisms, let us take an example of you may say a tiger. So a tiger is there. So there is no such limits now that no, I need to control my population. I need to afford the living of my offspring. It is not like that. So why is not like that? A tiger gives rise to a huge number of offsprings, and in the world there is all tiger. It is not like this because there is environmental resistance. Environmental factors limits the population size either by reducing the food, either by reducing the habitat. For example, tigers or lions are being reduced from the number what they were in about 100 years ago. So their numbers are constantly being reduced. Why is it? It is because we are cutting down forests and limiting their habitat. So this decrease in their habitat is again an environmental resistance, which is going to rise in accordance to the population size. For example, if there are 100 tigers, they can live in a smaller area. So if the 100 reproduce again and again and produce a population size of 1,000, now that much smaller area which was sufficient for the 100 tigers now become insufficient for the survival of 1,000 tigers. Maybe it maybe due to unavailability of food, maybe due to unavailability of mate or anything like that. So the population is being restricted to a limit by the environment. And how does environment does that? It creates resistance. So environmental resistance has an influence on the biotic potential of an organism, and that is represented by k minus n by k. Okay, now what is k, what is n, we will be dealing it with in the next paragraph. Now again, k is carrying capacity. The next term is given itself. Now k is carrying capacity. So carrying capacity is the maximum number of individuals of a population which can be supported with optimum resources for the survival. For example, what I said in the just previous example was that a land which was sufficient for 100 tigers is now insufficient for 1,000 tigers. So sufficient for 100, but it that much land mass can afford to survive what something like 200 or 400 tigers. Okay, so that 400 is the carrying capacity of that environment. It is not about that tiger or some species or anything other. It is about environment, that no, this environment can support a maximum of this number of an organism. Okay, so this is carrying capacity. Again, growth of a population depends upon the biotic potential, death rate, and birth rate. Depending upon the amplitude of these three, means depending upon the value of these three, the population may show two types of growth. The first is exponential growth, and second is logistic growth. Now, what is exponential growth? Okay, wait. Let me first come back to this. It was left now. Yes, this formula. This is an important formula. I urge you all to remember this. K minus n by k. K is the carrying capacity, n is the number of individual which is residing in that area. Okay. So this is environmental resistance. Okay, so environmental resistance is uh, k minus n by k. Now moving forward, there are two different types of growth models. The first is exponential and the second is logistic. Exponential growth model is seen when there is unlimited resources. Important, very important for NEET as well as for your boards. When the resources are unlimited, the organisms grow, you can say, without any pause. They just grow. And after some time, when the conditions are unfavorable, their population also retards in the same way and they vanish. Okay. Okay, but let me first introduce you with two, three more terms. The first one is R. What is this R? R is called intrinsic rate of natural increase. Intrinsic rate of natural increase. R means how much a population can grow. What is the inbuilt instinct of a species, of a population to grow? This is denoted by R. More is the R, more faster is the population growth. So the magnitude of R was 0.025 for human population in India, which reached to about 0.0176 in 2001. Okay, means it was declining, na? Again, Norway rat, it is for Norway rat it is 0.015. For floor beetles it is 0.12. Look at this, 0.1 here, 0.0, yeah, again 0.0. So this is higher, and you all can see ना, if even a smaller beetle, हिंदी में उसको सूही बोलते हैं, जो आटा वाटा में कीड़ा लग जाता है। देखो एक भी कीड़ा अगर आटा में घुस गया, उसके बाद तुरंत से पूरा आटा को में कीड़ा भर जाने में ज्यादा समय नहीं लगता। क्यों? क्योंकि उसमें पॉपुलेशन ग्रोथ का इंस्टिंक्ट बहुत ज्यादा है। 0.12 is the value for that floor beetle. Again, now again come for that equation. Wait, this is what I mean by exponential growth. What you see is that uh, the population is growing, growing, growing. Achha, let me take an example. In monsoon, you see so many insects are mm, appearing in a very fast rate. No? What I mean by this is that in monsoon there is plenty of rainfall. Plenty of rainfall leads to plenty of vegetation. Plenty of vegetation leads to a plenty of, or you may say, variety of food for the insect. And in this extreme availability of food, when food is not a factor for which is something like resistance for the population growth in case of insects, they just grow, 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 and suddenly when the resources become depleted, it means that when monsoon is over, now winter is approaching. So as soon the resources are depleted, these population decline at a very fast rate and get vanished. So the equation for this type of growth is dn by dt is equal to rn, and this type of growth is known as geometric growth or exponential growth, and the curve is j-shaped. Again, very important. So such population stop abruptly due to environmental resistance, which become effective suddenly, है ना? अचानक से मॉनसून खत्म हो गया या बारिश आया था, पानी पूरा हर तरफ भर गया, घर के आसपास में जो खाली प्लॉट था उसमें, तो पूरा पूरा उसके ऊपर यू कैन सी दैट एल्गी ग्रोथ इज वेरी मच, डजंट इट? एल्गी ग्रोथ इज एक्सट्रीम, पूरा पानी हरा हो जाता है। बट अगेन, just as the monsoon ends, the water level is declining due to extreme sun or some any other factors, you will see that all the algae growth suddenly vanishes, तुरंत से खत्म हो जाता है अचानक से। तो environmental resistance इसमें अचानक से आता है। So algal bloom, insect population in rainy season, again these population growth is called R selected species, very important. So this is for exponential or geometric growth. Exponential or geometric growth. Now again is logistic growth. Okay, so one more class will be enough for it. These may look larger, but it is a smaller part. Okay, again, logistic growth. So logistic growth is some growth in which uh, there is not like rapid increase in the population. It is gradual, step by step. So this growth form is characterized by a function of carrying capacity for a given population, giving it a more realistic form. This carrying capacity was not in play in case of exponential growth, क्योंकि अचानक से बहुत रिसोर्स आ गया था. तो अचानक से रिसोर्स आने की वजह से कैरिंग कैपेसिटी मतलब मैक्सिमम एबिलिटी ऑफ द इन्वायरमेंट ये बहुत ज्यादा बढ़ गया था. बट जैसे ही आप इस केस में बात करो लॉजिस्टिक ग्रोथ में, तो यहाँ कैरिंग कैपेसिटी भी वी कंसिडर, and that is why it is more realistic. This growth form was given by Verhulst Perl. So it is also known as Verhulst Perl logistic growth, and the expression for this is dn by dt is equal to rn into this carrying capacity. And what you see here is, yes, this. This is again a sigmoid graph. S-shaped graph is there, isn't it? So in this case, you are finding a J-shaped graph. Here you are finding a S-shaped graph. Okay. Now again, the last topic for today's class. What is R? So uh, populations evolve to maximize their reproductive fitness. So why do population evolve? So population evolve to make changes which in turn leads to maximize their reproductive fitness. And for organisms that breed only once, example you need to learn only bamboo and Pacific salmon fish. Yes, bamboo you studied in chapter 1, no? Again, organism bred many times, most birds and mammals. Organisms produce a small number of large sized offspring. Birds and mammals, we are having one offspring at a time, no? But the offspring is of large size. Organism produce large number of small size offspring. Fishes, oysters, etc. Okay. So this is all for today. In next lecture, we'll be trying to complete this whole chapter. Okay.